Hi, this is Azure Biosystems, and today we are going to cover the basic 1D module workflow in the AzureSpot Pro analysis software from Azure Biosystems. AzureSpot Pro analysis software offers modules for 1D analysis, array analysis, a colony counter, as well as a toolbox analysis module. Today we are going to cover basic analysis using the 1D module. AzureSpot Pro is designed to walk you through the analysis process. A step-by-step guide in the right-hand corner of the window will tell you exactly what steps to take in each section of the analysis process. If at any time you need more information or a more in-depth explanation, click the Help button to go to the relevant page in the user manual. So, as our little guide up here says, the first step to analysis is to open your image. As soon as the image is open, you will see these two cyan graphics at the top above your image. These two graphics display your signal in cyan and background in black. The graphic on the left will highlight saturated pixels in red. If all your pixels are in cyan, you're all good. Otherwise, if you see any red pixels, those pixels are saturated. You can zoom in on any section of your image by clicking the zoom button and clicking and dragging to highlight a specific section that you'd like to view. You can revert back to the original image by pressing the reset zoom button. The right graphic is a 3D model of your image. The 3D model is a great aid for viewing signal trends and for determining whether your signals are in the proper orientation for analysis. Proper signal will be cyan hills above a black background. If your signal is inverted, you'll instead see craters, black craters in a cyan background. If your image opens and you're seeing craters instead of hills, click the three dots next to your signal channel and select Invert Measurements. To adjust the display and contrast of your image, click the Contrast button and use the sliders to adjust the contrast of your image. You can view the full data range of your image by clicking Full, or auto contrast it by clicking Auto. You can also select Manual for more fine-tuned control of the contrast. From this menu, you can also select the pseudo-coloring of your image. There are several pseudo-colors to choose from, including several heat mapping options and presets for Kumasi stains and silver stain. All these color options are pseudo-colors only, so changing the color does not affect your data, only the way your data is displayed. Once you have checked for saturated pixels and verified that your signal is in the correct orientation for analysis and contrasted your image to your liking, you can move on to the next step of analysis, which is to create lanes. With AzureSpot Pro, you can analyze a single gel in your image, or you can analyze multiple gels and blots in a single image by creating multiple lane boxes. So with this image, for example, I could create two lane boxes to analyze this gel as two separate sections independent of one another by creating two separate lane boxes. I can now adjust and edit the lane boxes by using the diamonds to move and the squares to adjust and bend. And you can see that I can manipulate them independent of one another. I can add additional divisions into each of my lane boxes in order to more finely tune the adjustments I make to my lane boxes. Or if I have an adjustment to make to an individual lane, I can edit lanes and again use the diamonds to move and the squares to bend and manipulate. At this point, you can also rename your lanes in order to annotate your image further. Once you are satisfied with your lane box and individual lane placement and manipulation, you can move on to the next step in analysis, which is background. When you enter the background definition tool, you'll notice a data table appear. You can select what data is displayed in the table by clicking the Choose Columns icon. In this case, I'm going to select to view my volume, my raw volume, my band volume, and my raw band volume. So you can see there are now columns for the volume and the raw volume, which at the moment are the same, as well as columns for the band volume that we will get to when we get to the band tool. On the right, we have the signal profile of each individual lane, which you can view by selecting your lane in the image, or you can select lanes from the drop-down to view individual lanes or to view multiple lanes. And as usual, the software will walk you through exactly what you need to do in each tool in order to analyze your image. AzureSpot Pro offers several background subtraction methods, including none, rolling ball, rubber band, constant value, and image rectangle. None, as you can imagine, subtracts no background from your image. Rolling ball takes an imaginary ball and rolls it underneath your signal and subtracts everything below that as background. Rubber band takes an imaginary rubber band and stretches it up against the profile of your image and subtracts everything below that as background. Constant value will take the minimum value in each profile and subtract that as background. Or you can select a value to subtract globally across your entire block or image. Image rectangle allows you to draw a rectangle on your image and have that subtracted as background. Again, if you need more explanation on the different background types or more information about background subtraction, click the Help button to open the background definition section of the AzureSpot Pro manual. For this image, I'm going to use rolling ball as my background subtraction method. With rolling ball, you can adjust the radius of the ball with this slider or by entering a number here. The radius number displayed is actually a fraction of the lane length. So a larger number is going to be a smaller ball because it is a smaller fraction of the lane length, whereas a smaller number is going to be a larger ball because it is a larger fraction of the lane length. For example, if I have a radius of 3, I'm going to apply that background method and I will display the background so you can see how that ball is rolling underneath all these hills. If I change that to a much larger number, so a much smaller fraction of the lane length, and apply that, you can now see how that ball now falls into those hills of signal because it is a smaller ball. Once you have chosen your background subtraction method and subtracted your background, it is now time to move on to bands. Once you have entered the band definition tool, you'll again see the data table displayed on the bottom left corner. You can click to select what columns you would like displayed. And the data for each band will appear once you have detected bands. AzureSpot Pro gives you several methods of detecting bands. You can go directly to the image and left-click on a band to detect it. You can also right-click to delete it. you can go into the image profiles and click and drag lane boxes to detect bands. And you can also right-click on a spot to split a band box, or right-click to delete bands. AzureSpot Pro also gives you the option of automatically detecting bands according to your set parameters. You can choose different edge modes such as single edge detection, automatic detection, fixed width detection, which will create every band box to the exact same width, or percentage of peak detection. Once you've set your parameters, click Detect Bands to detect bands across the entire image according to your parameters. After detecting bands automatically, you can still interact with the profile and with the image to delete bands by right-clicking. Once you have detected your bands, you'll see the data table now displays all of the columns and information that you selected. For many users, this can be the end of your simple analysis, creating lanes, subtracting background, defining bands, and determining their volume. For those who want to get a little bit more out of their image data, we move on to molecular weight. The molecular weight tool in AzureSpot Pro allows you to apply your molecular weight standards and markers to your image in order to determine the weights and sizes of your bands based on the interpolated data from the curve created by your molecular weight standards. In the band data table, you will see a position column along with a position unit. The default is currently at millimeters from the top of your gel. And once you apply a marker and create a standard curve for your image, that will change to the unit of your choosing. You can add your standard curves by clicking the Edit Molecular Weight Standard Templates. You can add new templates by clicking the plus sign and adding in any values present in your marker. You can also choose the unit and give your template a name. Once you have your most used templates stored in the software, click Change to select the template you'd like to use, and then click on your marker lane to apply the template. Once your template is applied to the specific lane you've chosen, a graph will appear. You can choose the line fit for your curve based on your SOPs or the manufacturer's directions for your standard. Once you have set your curve, you'll see that the position and position units have updated in the data table to reflect your template being applied to that gel. You'll also notice that because I created 2 lane boxes, back when I created the lane boxes, there are 2 curve boxes. This would allow me to apply a different template to my second gel if I desire to do so. For most users, this workflow of creating lanes, subtracting background, defining bands, and determining the molecular weight of your bands is all you need, and you can move on to the Results tab. From the Results tab, you can view all the lane data and all the band data generated from your analysis. You can select which lanes you would like to view, or select all lanes. At this point, you can also fine-tune the data displayed in your band table and your lane table, and choose to include any detailed appendices. Once you have selected all of your desired data, click Export CSV to export your data to a spreadsheet. For more AzureSpot Pro analysis training, visit AzureBiosystems.com.